Here we have a Mercedes Key Fob. This one is 1998 C230 that came in for repair. And the fob is the one with the triangle panic button in the front. And what that means is lower success rate working on those fobs than any other Benz fob in the market. Customer said the fob does not work. Sometimes it turns the vehicle on, sometimes it does not turn the vehicle on, sometimes it locks, sometimes it doesn't lock. And a known issue with those fobs. That's how the fob looks like. And right now what I want to do is measure to see if the fob is outputting frequency and infrared. So I have a battery pushed in from the back, and we're going to use a fob tester just to monitor if we have frequency and IR. And if we do this, we have a 0 reading. If I point my fob and press the button, we do have IR, but we do not have frequency. We should be reading about 314 frequency, but nothing. I do see the light on the fob when I press the button. We are getting IR signal. Look at this. Yeah. IR is good, but frequency, when I point to this side of the fob tester, we should be reading 314.9. Now the customer did mail over a donor board that we can use to fix this board. So let me go ahead and test the donor fob and see if we have frequency also. The problem is the firmware chip on the board that requires reballing based on my experience working on those fobs. So I do have the donor fob here, and let's see if we get 314.9 right there, 314.3. Okay, so the donor fob is good. It's outputting the proper frequency. And in this video, what we're gonna do is I'm gonna transfer the firmware chip over to the donor fob. Easier said than done. This is not a regular normal chip. This is a BGA chip right there. They come in many different names, and one of the names is Apple. So let's go ahead and remove this chip from the donor fob. We do not need it, and we're gonna transfer the customer's chip onto this good working board. A lot of times it's a broken pad on the chip itself or a broken pad on the board itself. Let's start by working on the donor fob. We're gonna remove the chip. We do not want to burn the button, the plastic on that button, so we want to point hot air onto the chip. I'm using a very small nozzle. Those nozzles are sold on our site for at-in hot air stations, the ones that we sell, and also quick hot air stations. Whatever we are using in this video can be purchased directly off our site. A lot of items are currently out of stock. We are working with vendors as far as tariffs go. And I want to keep prices to a minimal. Right now our prices increased on many of the items, but I want to try to get those prices back to normal, even if we take a hit on our profit margin, and maybe the vendor can work with us. So we're working on it. We have a lot of people waiting on the microscopes. We are working on getting those cameras in. So keep checking. Just when you log into NorthridgeFix.com, you click on shop and you want to buy products. If an item is not in stock, just click on the button, notify me when the item is back in stock. And once we have the item in stock, we will push on that button where it's going to send you an email to let you know that the item is back in stock. Easy. Now that we remove the chip, let's go ahead and wick unleaded solder balls from the board. Let me take out that glove. That's almost looks like I'm at war with that glove. It's ripped from all over the place. Fume extractor on. And we're gonna tin those pads before we wick. And the reason is, if you try to wick solder balls that are made of unleaded solder, most likely you're gonna rip off one of the pads on the board. Leaded helps lower the temperature of unleaded. It mixes with unleaded and it's easier to wick and work with. We have a lot of glare, and you know what to do when we have a lot of glare. For those who purchased our anti-glare light, let's look at the magic. 1, 2, and 3. Magic. No more glare. The colors are more vibrant. And people ask, why not use the anti-glare light all the time? Why switch between ring light and anti-glare light? If the anti-glare light is so good, why not use it all the time? Because you get different views, different sources of light when you use the ring light. Sometimes you want to use the ring light to fill in the shadows. Anti-glare light does not fill in the shadows. What I mean by that is, let's say you have a component like this button here. You see how that button is casting a shadow? The anti-glare light does not fill the shadows. Now if I turn the ring light on just a tiny bit, look, I can fill the shadows because the light is coming from the top. So you use a combination of the ring light and anti-glare light to get the best possible image. And the image that you see is really light. If you have poor lighting, then you're gonna have a bad image. The image that you see is a combination of a good quality camera, microscope, and a good source of light. The microscope alone is not enough, and the light source alone is not enough. You need both. Just like professional photography, you can have the best camera, full frame sensor, the best lenses. If you do not have a good light source, you're not going to take good images, good photos. So one thing we need to note is where pin number 1 is. Now I have the anti-glare light on, but since we do not have any reflections, we are losing out. We have shadows. We fill in the shadows with the ring light, like you see now. Pin number 1 is on the top left as I have the board oriented. See, look at this. We have a ripped pad. That ripped pad came off the chip. And that's a very common issue with those fobs. It's either a pad ripped from the board itself or from the chip. Most of the times from the chip. What can you do? So this ripped pad of the chip, and I've done many videos about the exact same issue where you have ripped pads of the chip. What we need to do is we need to zoom in a lot and we need to restore that pad in the best possible way that we can. Reball the chip and solder it back on the donor board. Like I said, it's easier said than done. Now we can probably use the same board because the pads on the board, they look good. But since we already have a good working donor board, I do not want to take the risk to solder the chip back on this board where this board may have other issues. The other board already tested good, so we're going to use the other board. And this is what we are working with. A small chip with small solder balls and traces that you cannot see, even with a microscope. Viewers always ask me to compare the size of what I'm working on to a penny or a quarter. And that's a penny right here. That's the size of the chip. But it's not about the size of the chip. It's about the size of the solder ball or the size of the trace that we're going to be working with to restore this pad. What is the size of that trace? You cannot compare it to a penny because there's nothing on the penny that equals the size of that trace. That's how small that trace is. If I work on the chip like this, I'm not going to be able to restore nothing. I need to zoom in a lot. That's how tiny the stuff is. It looks nice and big under the microscope, but the stuff is really tiny. Now what we're gonna do is use a chip holder, because right now if I try to work with the chip like this without a chip holder, then the chip is gonna move all over the place, especially at a high magnification. Things are gonna be very shaky and very wobbly. So we're gonna use a chip holder. We're gonna put the chip inside and squeeze on it. The camera likes to focus on my beautiful eyes, so I need to cover my eyes. What can you do? Okay, so the chip is secured. Now we can zoom in, then we can use our anti-glare light, because right now it's very difficult to see anything with all the reflections and glare. But before we do anything, we need to clean all the unleaded solder balls. Again, we're gonna tin the solder balls. I'm not scraping, I'm just tapping. And my wife is calling. Always at the wrong time. Hello? She tells me, when is a good time? It's always the wrong time. She's right. The problem is me. Right, so we're gonna use our anti-glare light. Let's see the difference. Look at this. Look at this. We can see every trace on that chip now. And tell me the anti-glare light is not magic. We have two missing pads, not one. The other one was still there, but it was weak, so it came off. Same exact issue like the last video we did reballing that chip. We had to restore two traces. I thought we got lucky on this one and we only have one, but no, we have two. So now we're gonna fill in the shadows with the ring light. So here I'm using the NorthridgeFix brush, 99% isopropyl, and Kimtech wipes. You can use anything over 90% alcohol, isopropyl. Do not use 70%. If you live in the US, you can go to Target, and I believe they sell 92% or 93%. 99% you may find locally, or you may have to order online. That's amazing. We did an awesome job. I'm just gonna add a tiny bit of a solder mask, UV mask. UV mask is not really used as glue. It's not glue, but because the traces are so tiny, it can act like one. But that's not the main purpose of UV mask. UV mask is used to mask or hide exposed copper. Right, so we did an awesome job. Now it's time to reball that chip. Let me just quickly measure those pads in diode mode. We may get a beep or a diode reading, so I'm gonna check from, let's say, this pin here, just randomly. And I'm reading 1.7 voltage drop, and I'm reading 1.72 voltage drop. Awesome. So we know the pads are making a connection, because if those pads were not making a connection, then we would not get any readings. There's nothing specific I'm looking for as far as the numbers go, but as long as we get a reading, and we did. Now it's time to reball that chip, solder it back on the donor board, and hope for the best. I mean, we do have a good working donor fob, so there's no reason why this would not work. As long as the reballing is good, then we should have no issues. Now, we do not have a stencil for this chip where it's gonna block solder from going in the middle, but that's okay. This one will work fine, and it's gonna add solder balls in the middle, but that's okay. Now, this customer probably cannot get a key fob for this car anymore. Few customers came in and they said anything $19.99 and below, Benz will not even make you a fob even if you pay for it. I do not know how true this is, but that's what customers told me. Right, so I added Captain tape. And the way I do it every time I reball, what I do is I place the chip at the edge. I put Captain tape on the right side. I put Captain tape on the bottom side. And I leave myself room from the top and the side in case I want to adjust that chip. I can slip my tweezer under and adjust it as needed. The chip is good. I do not need to adjust anything. Simple, just use your finger with the gloves on, apply thermal paste. No need for a spudger, no need for a knife, no need for nothing. Solder paste made its way to every single hole, and nothing is more accurate than your finger. I do not care how many reballing videos you've seen before. This has to be one of the best ones that you watched, because there's a lot to learn from this video. We do not care about the middle balls. We do not care about the left ones, the right ones, the ones on the bottom. We care about the one on the chip. Okay, let's clean up and see what's going on. And that's what happens when we do not have the proper stencil for the chip. It's gonna get a bit messy. Okay, so we lost the pad completely. Let's reflow the solder balls on the chip, make sure everything is nice, and we'll fix that trace again and add a solder ball manually and see how it goes. Oh, wait a minute, we have two. What? No way. We have one more weak pad here. No way. Oh, look at this. Okay. All right. So I was confused. The two pads I restored are right there. They are perfect in every way, shape, and form. Look at the solder mask. Look at how nice they look. But we lost additional two pads, two weak pads. And that's what's wrong with those chips, with those fobs. Pads, they break off the chip. It's a known issue with the key fobs that have the triangular panic button. Now we need to restore this guy, and we need to restore this guy, and maybe we can apply a solder ball manually. More work. What can you do? The time it will take to fix this fob, I could have done 2-3 laptops. That's why I do not work on jobs that will consume a lot of my time, unless it's a good pay. It's not worth it for our business. It may be worth it for somebody who does not have business. He'll work on anything. But we have a lot of devices in the queue, and it just economically does not make sense to us to spend that much time working on one single device. Some people ask, do you replace CPUs? Do you replace GPUs? Why don't you work on that type of repair? Why don't you work on this type of repair? It's all about time. If it's worth our time as a business, we'll do it. If not, then somebody else can do it. If that fob had 4 pads to begin with, 4 rep pads, maybe I would not have worked on it. Now I'm forced to work on it because I already started the video, and what can you do? The area is tight, and we cannot touch the other solder ball, otherwise we're gonna tamper with that ball, and we're gonna have to reball the chip. So let's see if we can do it without tampering with the neighboring solder balls, and the area is tight. Now, if you noticed, this ball was tampered with. We touched it by mistake, and now it's not as big as the others. It's okay to have a slight difference between the balls because not all the pads on the chip are similar in size, but that's a big difference. Between this and this, it's a big difference. We may have to reball, or maybe we can manually add a solder ball on top of this. We'll see. But let's go ahead and restore this one. And that's why sometimes working on this fob is not a guaranteed fix, because we may have other weak traces on the chip. Maybe another trace is broken, or it's not making a good connection, and the fob will end up not working after we reball and solder it back on the board. We cannot recreate traces for every pad on that chip. It becomes a non-practical repair. That trace is so tiny and so close to the other solder ball. You cannot imagine how tiny and how thin this wire is. Seeing is believing. That's if you can see it. All right, so now we're gonna keep the solder balls as they are, and we're gonna do the reballing over them. We're gonna have to clean the stencil first. Now, as you can see, some of the solder balls, they jumped over and made a connection with the solder balls that we care about. What we can do in this case is we need to scrape off the axis and redo. Right, and now all we have to do is reflow and we should be good to go. We can apply a tiny bit of flux, it doesn't hurt. Very nice. Look at this. Look at this. Let's remove any middle solder balls. We do not need them. Now I'm going to put the chip in the chip holder again. I want to clean it. Wow, beautiful. Beautiful. Now all we have to do is solder the chip on the donor fob and hope for the best. And when I say hope for the best, it means we're gonna hope that all the traces, all the pads on this chip are making a good connection. Otherwise, if there's a weak trace or a trace that's broken that we cannot see, then that fob will not work. We're gonna go to the donor fob. We already removed the chip. We cleaned the board. So the board is ready to accept the new reballed chip. Very nice. Very nice. We tapped on the chip, it's settled in place. We know the chip is soldered on nicely. Let's wait until solder cools down. The board is only 2 layers, so we have to wait until everything hardens, and we do not want to touch any components yet. Maybe 15-20 seconds to be on the safe side. I do not want to cool it off with alcohol. Just let it cool off for 15-20 seconds, then we can clean the board. Tap on the side. All right, so let's see. I have a couple of batteries on my bench. I just want to make sure that we have the good working battery. I forgot which one was good. .07. What about this one? 2.9. I'm gonna throw this one away so we do not confuse it. For a good battery, 3.05. So let's use this one here. 3 volts. It's working. So if I press on the button, watch, 314.9. Look at this, 314.9, and if I point on top, we have IR. Okay, so we know infrared is working, and we know that we have frequency. Wow. We're gonna end the video right here. I hope you enjoyed it. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.